So let's begin. All right. So we are project number 4 under MFE, as Professor Zoro just explained, blockchain manipulation analysis. Quick table of contents. I'm going to give a small introduction to the team. We're going to discuss our problem statement and our motivations. We're then going to go over a general overview of our methods, which is just a high-level look at things that we've come up with. Then we're going to branch off into 2 major parts: market manipulation detection, the use of mathematical models that we have come up with in order to detect manipulation within crypto markets, and wallet tagging software. So here we're going to discuss the data science and database approaches we have come up with for wallet tagging. From there, we'll move on to use cases and possible future directions and how this software could specifically fit in at JSL. Let's begin with a short list of introductions. My name is Abhishek Kumar. I'm a computer science major here at Lehigh. I have a background in pure mathematics and theoretical physics, but now I mainly focus on quantitative financial modeling. I have been researching and building mathematical models for around about 7 years.
Hi, my name is Gregory. My projects have been primarily focused on large language models, creating trading algorithms, and machine learning interpretability in both undergrad and graduate school.
Hi, my name is Fatmat, and my project has been focused on large language model application, algorithmic trading, and machine learning application in financial analysis.
We'll move on to the general overview of our methods. For this, I'll pass it back to Bob.
Thank you, Akshat. I would say at a high level, our project.
Just don't worry about that. Yeah.
Yes?
Okay. I would say at a high level, our project has been focused on detecting market manipulation and bad actors in the cryptocurrency space by using market volatility via mathematical means combined.
So that's the general overview of our project. We move on to the problem statement and our work on market manipulation detection. For this, I'll pass it off to Greg.
The main issue in how cryptocurrency trading happens today is the fact that there's a lot of external actors or just bad actors in general. And what we're trying to do is introduce a series of mathematical methods so that we can identify this manipulation and potentially help people out in the progress to stop trade, to find these and not trade on them. An example of a scam, particularly a rug pull, is Squid token. As you can see here, there was a lot of different a lot of volume within like the first week. And then after that, it came down 80% because they were not ready for because the general trading population was not ready for the stock price to be that high. It just turns out that everybody was just there in order to, or sorry, the most amount of trading volume was just scam. It was the original people who were trading that held a token. They decided, okay, we're going to sell. And then they sold off enough that it impacted the price. And now the price has essentially gone to zero. Crypto rug pulls and scams have become endemic to the DeFi ecosystem, making up 65% of all total attacks. Between September 2020 and January 2022 alone, more than 212 scam tokens were created. And this is according to Solidus Labs.
Right. As Greg just explained, one of the biggest issues that we have within cryptocurrency market, and really something that affects DeFi as a whole, is the presence of rug pulls and scams, right? One example is the Squid Game token. This is a very notable example of a rug pull where the token's price is artificially inflated, pushed high, and then the bulk of that currency is sold off, or investors lose access to their funds, right? So this is one example of external market manipulation, and this is the sort of thing that we are hoping to catch with our mathematical methods. So with that said, let's get into exactly how we're going to do this, right? Now, it's clear that with some kind of human team, we can qualitatively work out whether or not a token is likely to be fraudulent or illegitimate by analyzing blockchain data, by looking at price history data. One can generally work out an idea of whether or not a token is legitimate. What we want to be able to do is to create a quantifiable metric, a mathematical and software-based approach that can be used to do this identification essentially automatically. So we want to be able to detect tokens that are themselves some form of fraud or illegitimate token, but we also want to be able to work out the amount of manipulation within a more established token in some form of quantifiable manner, right? So with that said, let's move on to our primary results. Essentially what we do is we take the volatility data using the price history of the token, and from there we fit it to a stochastic volatility model and solve for the parameters of that volatility model. What we find is that the parameters of this volatility model can be used very reliably in order to pick out which coins are possibly scams and which ones are not, right? So if we look here at the graph on the right, we have three main parameters: kappa, theta, and chi. Here we can see kappa, theta, and chi plotted against each other for different forms of cryptocurrency. The dots that are shown in blue are legitimate cryptocurrencies, and those shown in red are illegitimate, fraudulent, some kind of scam, some kind of rug pull. We can clearly see that there is a clear partition in all three of these graphs, meaning that we can easily train some kind of binary classification model or support vector machine to carry out some kind of analysis given these parameters on the likelihood that a coin is some kind of scam or has some kind of external manipulation at play. Note, one very important fact, the points shown in red, the data taken for these points was taken before the rug was pulled for this specific crypto. So that means that this binary classification model would have a predictive ability. Now let's move on to analyzing the level of manipulation within a market. Now that we have these three measurements, kappa, theta, and chi, that tell us some kind of idea about the amount of external manipulation within a crypto market, what we want to do is we want to essentially work out a rolling kappa, a rolling theta, a rolling chi. In the same way that given price history data, you can work out a rolling volatility. And we want to use these rolling metrics as a measure of the amount of manipulation within a crypto market. Here, we can see an example of this, right? And obviously being able to do this would allow us to create the aforementioned quantifiable metric, the numerical metric. And if you see here on the right, I have an example. Here, the graph's shown, there is a large spike corresponding to around about December 23rd, 2020, and more generally to the week of December 20th, 2020. And what we are studying here is the rolling theta, the rolling chi of Dogecoin, the Dogecoin token. Now, as we can see here with the black line, Elon Musk made a series of tweets on December 20th, 2020, early in the morning, centering around Dogecoin. Effectively, he acted as an external factor on the market, and we can very clearly see this reflected within the data. That brings us to tagging and relating bad actors. Here we'll be going over our software, data science, and data-based approaches to identifying bad actors within the market through on-chain analysis. So let's discuss the general algorithm design of the wallet tagging algorithm. We begin with a small seed list that comes from some set of prior knowledge. We carry out multi-hop analysis in order to get an extended list, some kind of visual view of the way in which funds are moving. This gets stored in a main visual database. From there, we run it through our tagging algorithm, which I'll get into in a minute, which uses external data in order to generate a list of tagged or suspicious wallets. These wallets go in their own visual database, and from there, they can go in some external database, something more traditional. And the idea is, as this program runs over time, there will be a historic list of wallets that are tagged in some suspicious manner that we can then tag and track, and we can report the movement of funds through these suspicious wallets. And how that is useful, we'll get into that in a minute as well. So let's begin with our tagging algorithm steps. Let's begin with the seed and multi-hop analysis. For this, I'll pass it back off to Fatma.
Thank you, Akshat. I would say, as Akshat previously said, we start with a seed identification, which can include known or suspected suspicious wallet based on prior scams, fraud detection alert, sanction evasion, or external data sources like news. These seed lists serve as a starting point, focusing on wallet with existing suspicion. Next, we perform the op analysis to identify wallets that are directly connected to our seed list, known as the first degree ops. We expand further to second degree ops and beyond, creating a more comprehensive network, as you can see on the right side of the slide.
Exactly, exactly. As Fatma just explained, what we essentially do is we begin with a small seed list that comes from some kind of prior knowledge. And then using the seed list, we analyze on-chain data in order to find the wallets that have transacted with this specific wallet, and we add them to our database. And this can be done recursively until we have a large comprehensive list that can then be analyzed using the tagging algorithm. Now, the way the tagging algorithm works is it will look at the external data and it will look at the shifts in volatility of the external data. If we see large shifts in the volatility of the external data, we can imagine that there is some kind of movement happening. Now, if around that same time we see a large transaction between a set of wallets, that transaction is tagged as suspicious. Now, of course, it's possible that a wallet is simply coincidentally trading at a time when there is high volatility in the external data. So the way we tag the wallets in specific is if we see a repeated pattern of high volume transactions happening at times when there is high volatility in the external data, if we find a repeated pattern, then this wallet is tagged as suspicious and put in the database for tagged wallets, which then moves into the historical external database. Here on the right, we can see an example, an initial cluster of possibly suspicious wallets we wanted to analyze, and then we can see how it cuts down to a small set of suspicious wallets. This is within a sandbox environment that we created to test this out with. Essentially, we want to find a needle in a haystack, so we make the haystack first, and then we find a needle. That brings me to possible use cases and next steps. For this, I'll pass it off to Greg.
Thanks. So we've already demonstrated that we can quantifiably measure manipulation in the crypto space. We are also able to tag suspicious wallets and also see the flows of funds from these wallets. This can have a lot of applications. Just starting off, we can track wallets that are involved in multiple fraudulent currencies and then see what other actions they're doing in other currencies. We can also help detect more rug pulls via the binary classifier that we talked about earlier, which could avoid and help in avoiding bad investments. Most importantly, the versatility of the tagging algorithm is what lets us do everything here and is what allows us to apply this to other situations. There's always more types of sanction evasions, for example, with Iran or terrorist groups. And then there's even more possibilities. Being able to track in real time the extent to which the crypto market is being externally influenced can provide investors a great way to have a quantifiable way to mitigate risk. And this is important when it comes down to, for example, recommending what sort of cryptocurrencies to recommend to clients. We're also looking to expand our analysis to include data from the social media sphere, for example, Twitter, Instagram, Blue Sky, and looking at these cryptocurrencies within these social medias, and then also being able to analyze even more on-chain data.
Okay. As my partner Greg just explained, this technology could have multiple possible use cases. For example, one thing he mentioned is that the tagging algorithm that we have is extremely versatile. I purposely mentioned external data generally because really this can be any kind of data from the compliance aspect. Say we're looking at the misuse of cryptocurrency instead of, say, a rug pull. Then we can put in data that corresponds to some form of misuse. And then with the right seed list, we could possibly work out wallets and we could tag wallets involved in that form of misuse. One example of such misuse, of course, would be the use of cryptocurrency for sanction evasion, which has been a hot button topic especially in politics as of recently. Another possible use, especially of our rolling metrics, is a study of the amount of market manipulation within the crypto market as a whole. As we are aware, there are things such as whales, and there's many forms of external manipulation within the crypto market. So being able to work out in some quantifiable manner the amount of manipulation as a whole in the market would be extremely useful. So here I direct you to the right of this presentation. Here what I've done is I've simply taken the rolling theta of the top 5 cryptocurrencies. So established cryptocurrencies like Bitcoin, Ethereum, TRX, many more, right? And I work out the aggregate rolling theta of these coins. This essentially gives us an idea of the amount of manipulation in the market as a whole. And being able to access data like this could be very useful for investors looking to invest in the cryptocurrency space as a whole. So this brings me to my last slide. What does JSL specifically stand to gain from these technologies? So essentially, I want to discuss how these technologies could come into play from an investment consultant perspective. So from that investment consulting perspective, there are many ways that this technology could aid JSL in allowing investors in this space to generate value and, most importantly, mitigate their risk. The first is being able to identify bad investments. Using the binary classifier that I showed early on in the presentation, one can work out which tokens are likely to be scams and which ones are likely to be fraudulent and which ones are likely to be legitimate. This can be a useful tool in helping investors avoid bad investments in the cryptocurrency space. Now, next we move on to identifying bad actors. Having a database of known bad actors in the cryptocurrency space would have many uses. One example is identifying bad investments through correlation. If you analyze the on-chain data of a certain upcoming project and find that many suspicious actors have been making many high volume trades, you can likely work out that that new project is going to be illegitimate in some way. So this is another way in which having that database of bad actors could help from an investment consulting perspective. Again, there are many trading strategies that are based on volatility-based data, and our model essentially studies the volatility of the crypto market. So there are many strategies that could be built on top of this data. Next is quantifiable metrics for risk mitigation. As I just showed on the previous slide, if we have quantifiable metrics for the amount of external manipulation in the crypto market as a whole, we can aid investors in mitigating their risk. And lastly, I want to make a more general point that the mathematical and software-based tools here can essentially provide safer investment strategies for cryptocurrency as a whole. These methods can help develop safe and stable strategies for investing in cryptocurrency. Currently, one main reason many investors are hesitant about investing in cryptocurrency is this kind of external manipulation and this fear about the volatility. If we can use tools like this to navigate that, we can potentially attract more investors to this space. And that brings me to the end of our presentation. This is our contact information. Now we'll take questions.
You could stop sharing the screen, actually.
Hey, well, thanks for the presentation. That was really good. I know Steve Straubelin joined at some point throughout this with a noisy background. If you wanted to say anything now, Steve, it's your chance.